Quadratic functions. So in this video we're going to talk about quadratic functions and how to graph them and all these properties. Now, why we're studying quadratic functions? Many sports involve objects that are thrown, kicked, or hit and proceed with no additional force. Such objects are called projectiles, and paths of projectiles are modeled by quadratic functions. So a quadratic function in standard form is as such: f of x equal ax squared plus bx plus c. Now, the graph of quadratic function in standard form: if a is positive, we have a parabola concave upward, and we have the axis of symmetry that has an equation x equal negative b over 2a. We have the minimum, which is the vertex, and when a is negative, we have a parabola concave downward. Also, we have an axis of symmetry with the equation of x equal negative b over 2a, and we have the vertex is the maximum point. So let's take the first example. We need to graph f of x equal x squared minus 8x plus 12. First of all, a is positive. A is always the number attached to x squared, so the parabola is concave upward. We need to solve for the x-intercept, set f of x equals 0 and solve for x. Therefore, the x-intercepts are 6 and 2. Now the vertex is negative b over 2a and f of negative b over 2a. So my a is 1, my b is negative a. Therefore, negative b over 2a is 4, and f of 4 is negative 4. Now we need to solve for the y-intercept. So f of 0 is 12, therefore the y-intercept is 0, 12. Let's graph it. Now don't forget, the axis of symmetry is x equal 4. Now the domain is negative infinity to positive infinity, and the range is close at negative 4 and to positive infinity. Now another example, we need to graph f of x equal negative x squared plus 4. So a is negative 1, it means the parabola is concave downward. Solving for the x-intercept, set f of x equals 0. So we need to solve for the zeros. Therefore, x equal negative 2 and 2 are the x-intercepts. The vertex, my a is negative 1, b is 0. Therefore, negative b over 2a is 0. And f of 0 is 4. And notice it's the same as the y-intercept. So the vertex is the same as the y-intercept. So let's graph it. Don't forget, the axis of symmetry here is x equals 0. And the domain is negative infinity to positive infinity, and the range is negative infinity to 4. And don't forget that the axis of symmetry is x equals 0. So notice the vertex is the same as the y-intercept also in our case. Now, graph a quadratic function in vertex form. Also, if a is positive, we have a parabola concave upward. We have an axis of symmetry, which has a formula x equal h. Now, the vertex is the minimum, and the vertex has coordinates h and k. If a is negative, we have a parabola concave downward. Also, we have an axis of symmetry that has a formula x equal h, and the vertex is the maximum point. Keep in mind the vertex has coordinates h and k. So now we're going to learn graph of quadratic function in vertex form. So let's take the first example. We have f of x equal -2 times x minus 3 squared plus 8. So first, a is -2. It means the parabola is concave downward. The x-intercepts are 1 and 5. The vertex is h and k. So let's see what's my h, what's my k. So h is 3 and k is 8. Therefore, the vertex is 3, 8. Now, these are the x-intercepts. This is my vertex. And this is my parabola. Keep in mind, x equals 3 is the axis of symmetry. Now also, don't forget that we have the y-intercept is 0, -10. Now the domain is -infinity to +infinity, and the range is -infinity to 8. Another example, a is positive, a is 1, implies the parabola is concave upward. The x-intercepts, there are no x-intercepts because we got imaginary number. The vertex, h is -3 and k is 1. Keep in mind there are no x-intercepts. Let's put everything together. So this is my vertex, -3, 1. Now we need the y-intercept. And the axis of symmetry is x equal -3. And the y-intercept is 0, 10. Now the domain is -infinity to +infinity, and the range is 1 to +infinity. Now we're going to see application on quadratic function. So we have 600 feet of fencing to enclose a rectangular plot that borders on a river. If you do not fence the side along the river, we need to find the length and the width of the plot that will maximize the area. What is the largest area that can be enclosed? So what's the area of a rectangle? Is length times width. Now here the length is 600 minus 2x and the width is x. So we're going to substitute that, distribute the x. So notice the area, we got it as a quadratic function where a is negative and the maximum occurs at the vertex. Therefore, a is -2, b is 600, therefore the x of the vertex is 150. So the area is a quadratic function with a equal -2. So it's concave downward, so the maximum occur at the vertex. So x maximum here is 150. Is the width is 150 and the length is 300. Therefore, the maximum area is 45,000 square feet. A ball is thrown upward and outward from a height of 6 feet. The height of the ball in feet can be modeled by -0.1 x squared plus 0.7 x plus 6. Notice also we have a quadratic function where a is negative, so that's a function concave downward, and a is negative, so the maximum occurs at the vertex. What's the maximum height and how far from where it was thrown does this occur? Now, the maximum height occurred at the x of the vertex. So x of the vertex is negative b over 2a, and that's going to be 3.5. Therefore, y maximum, substitute that x in your function, is going to be 7.225. Therefore, the maximum height is 7.225 feet. That's 3.5 feet from where it was thrown. Now, how far does the ball travel horizontally before hitting the ground? So we need to set f of x equals 0, because when it hits the ground, it means there is no height anymore. It means the height is 0. So x equal negative 5, we can take that because we know certain things in math has to be positive. Therefore, the ball hits the ground at 12 feet from where it was thrown. Now this is a graph. So this is my ball, that's my maximum height at 7.225, and when it hits the ground at 12.